on my way. Now we go for number 2, exercise 4.2, question number 2. A minus B, B minus C, C minus A, B minus C, C minus A minus B, and then C minus A minus B, and B minus C. You want to show that this is equal to 0, right? Okay. So we start with the left hand side. A minus B, B minus C, C minus A, B minus C, C minus A minus B, and then C minus A minus B, B minus C. This is what we have. Now what I'm going to do is, to row 1, I'm going to add row 2 and row 3. To row 1, I'm going to add row 2 and row 3. To row 1, I'm going to add row 2 and row 3. Okay? Adding row 2 and row 3 to row 1. Then your row 1 becomes A minus B plus B minus C plus C minus A. Now, B minus C plus C minus A plus A minus B. C minus A plus A minus B plus B minus C. And then we have B minus C, C minus A. We have C minus A minus B. And now we have A minus B, B minus C. Here, plus A minus B plus B minus C plus C. Plus B minus B minus C plus C minus A plus A. Plus C minus A minus A minus B plus B. So row 1 is purely 0 now. So this becomes 0, 0, 0. B minus C, C minus A minus B. And then we have C minus A minus B, B minus C. Since all the elements of row 1 is 0, if any row or any column is 0, the determinant is 0. Alright? That's the most simplest way, which is your right hand side. So I'm going to do number 4. In number 4, I'll straight away write the left hand side. Left hand, you two have already done this, but for the video, okay? 1 BC A B plus C. 1 CA B times C plus A. 1 AB C times A plus B. Now, what we do is 1 BC, A times B is AB plus A times C is AC. 1 CA, B times C is BC, B times A is AB. 1 AB, C times A is AC, C times B is BC. Now what I'm going to do is, to column 3, I'm going to add column 2. So C3 goes for C3 plus C2. Then your determinant becomes 1, 1, 1, BC, CA, AB, and then we have AB plus, to column 3, I'm adding column 2, so AB plus BC plus AC. Column 3, I'm adding column 2, so AB plus BC plus AC. To column 3, I'm adding column 2, so AB plus BC plus AC. Now all the elements of column 3 are equal, AB plus BC plus AC, so I can take AB plus BC plus AC common. Then what we have is 1 BC1 1 CA1 1 AB1. Since two columns are identical, so in that case your determinant will become 0. So anything multiplied with 0 is 0, which is your required. Right inside. That's how number 4 should be done. Now we go for number 7. Number 7. Number 7, you want to prove that minus a square ab ac, determinant of, okay, and then ba minus b square bc, ca cb minus c square. You want to prove that this is equal to 4a square b square c square. So look on your left hand side. We have on the left hand side minus a square ABAC, BA minus B square BC, CACB minus C square. Is it correct? No? Now we have A as common on the first row, B as common on the second row, C as common on the third row. So from first row I'm going to take A common. From second row I'm going to take B common. From the third row I'm going to take C common. Now from first row I'm taking A common, so minus A, B, C. From the second row I'm taking B common, A minus B, C. From the third row I'm taking C common, A, B minus C. Now again, from the first column A is common, from the second column B is common, from the third row or from the third column C is common. From every column we have common. So this ABC as it is. Again, from the first column we have A common, second column we have B common, third column we have C common. Then what we get is minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Then we have now A square, B square, C square, and the determinant becomes minus 1, 1, 1, 1 minus 1, 1, 1, 1, minus 1. I can make as much zeros as possible. Okay, I can make as many zeros as possible. So what I'm going to do is, to row 2, you add row 1, and to row 3, you add row 1 again. Okay? Then, A square, B square, C square, minus 1, 1, 1, this becomes 0, this becomes 0, this becomes 2, right? This becomes 0, this becomes 2, this becomes 0. Correct? Now, to the second row, I can take 2 common. And from the third row, I can take 2 common. So A square, B square, C square. From the second row I'll take 2 common. From the third row, I'll take another 2 common. Then minus 1, 1, 1, 0, 0, 1, 0, 1, 0. Is it alright? Okay. Correct. Now what I'm going to do is this becomes 2, 2 times is 4, A square, B square, C square. And then we have minus 1, 1, 1, 0, 0, 1, 0, 1, 0. Now what we can do is, since we have the maximum number of zeros in your determinant, so we can expand your determinant now. Is it okay? We have maximum zeros, so we can expand the determinant. On row 1 we have 2 zeros. On row 3 also we have 2 zeros. So you can expand along row 2 or row 3. Or you can expand along column 1 because column 1 also has 2 zeros, right? So expanding along R1. Then 4a square b square c square r. Expanding along C1. Okay, let me expand along C1, not R1, okay, C1. Then minus 1, and if you take minus 1, then we neglect this row and this column. 0, 0 times 0 is 0, minus 1 times 1 is 1. The remaining elements will be 0. So 4a square b square c square times 1. That is 4a square b square c square, which is your required right hand side. It's very simple. Okay. So with this we end our class. We can just complete